This lesson's on triangle inequalities. There's multiple things you can use inequalities with in triangles to determine specific things. One of the first things being the triangle inequality theorem, which states a triangle exists if the sum of the two smaller sides is larger than the largest side. So what I actually have here is a program that has a triangle drawn for me where I have all the sides labeled. And notice we have three sides, 5.6, 5.65, and 7.24. The two smaller sides, 5.6 and 5.65, add up to equal 11.25, which is obviously larger than 7.24. So, does this work on every single triangle, or am I just giving you one to try to trick you? Let's see. So I'm going to take this point and move it around. Notice this changes the side lengths of the triangle. So I'm going to move it over here. Now I got 1.9 and 5.62. Right, if I add that together, I end up getting 7.52, right? Which again is still larger than that 7.24. Alright, well maybe I'm just have that one side set one specific way. See if we adjust this differently. So now I change that bottom side. Okay, so now I've got 1.9, 2.01, and then 3.67. Again, we're going to add the two small sides, 1.9 and 2.01, ends up giving me 3.91, which is still larger than 3.67. Now, this works on every single triangle that you have. The only way that I could end up getting these three lines to end up having where the two smaller ones are equal to the third one would be as if I move this point here down so that it actually overlaps here. So now if I actually looked at this, I have 1.99 and 6.52. If I add those, I get 8.51, which happens to be that third side. However, the trick with this one, this is not a triangle. This is actually a segment. Okay, we have a segment that it has two parts in it as well. In order for it to be a triangle, there has to be that open space in the middle. So, basically, through this example, we just showed that in order for it to be a triangle, the two smaller sides must add up and be larger than the third. If it's not, either the lines will not connect or it would make a segment. So let's actually look at how this one works. So let's say you're given three sides of a triangle, 8, 17, 24. And actually we don't know if this is a triangle yet or not because we're just told these side lengths. We have to figure out if it would make a triangle. So what we're going to do is we're going to take the two smaller numbers out of these three, which in this case is 8 and 17, and we're going to add them together. So 8 plus 17 gives us 25. Now we have to check to see if that 25 is larger than the third side that we were given. 25 is larger than 24, therefore we would know that these three side lengths could make a triangle. Let's look at another example. Let's say we were given the sides 3, 3, and 7. So when we do this, we're going to add the two 3's because they're the smaller sides. When we do that, we get 3 plus 3 equals to 6. 6, however, is smaller than 7. So these three sides could not make a triangle. Let's continue looking at other examples. Now, we got 25, 35, and 12. On this one, it's not in increasing order, so we have to still look which one's the smaller two. On this one, it would be 25 and 12. When we add those together, we get 37. 37 is larger than 35, so this could be a triangle. And we're going to look at another one, 52, 37, and 42. The two smaller sides are 37 and 42. When we add those together, we get 79. 79 is bigger than 59, so these three sides could make a triangle. Now, this isn't the only way that we can utilize this theorem. we could actually be given only two sides of a triangle and actually find what's all the possible numbers for that third side. Again, it's just using the same method. Let's look at an example here. We're going to use the numbers 14 and 22. So when we do this, we have only three sides that we can work with. Two of them have to be the smaller sides. So out of this, 14 has to be one of those two smaller sides because it is already smaller than the side that we're other side that we're given. So 14 has to be the smaller side. So we have two inequalities that we're going to set up here depending on if 22 is the middle number or if it's the largest number. All right, so we have an inequality where we're going to have something plus something is greater than something, and then we're going to have the other inequality where something plus something is greater than something. Now, we know 14 has to be one of the smaller sides, so 14 has to be on the left side of both these inequalities. Now, we don't know about 22 exactly, but it could be the middle number. So if it's a middle number, it would be in our first inequality on the left. And if it was a larger number, it would be in our second inequality on the right of it. So now we have 14 plus 22 equals to, or is greater than something, and 14 plus something is greater than 22. But we want to know what that something is. So in math, if we don't know what we're going to look for, we can always put a variable. So we're going to use x. So on the left, we're just going to work the entire way through. 14 plus 22 gives us 26. That is now greater than x. Don't have to work anymore because we got to what we need for x. On the right, however, we got to get x by itself, so we got to subtract 14 from both sides. When we do that, we end up getting x is greater than 6. Now, for the range, we're going to set it up, we're just going to do an inequality, something less than x, which is less than something. So we're going to always have the smallest one first, x in the middle, and then the largest one on the right. So the smallest number is 6. We're going to put x in the middle and put the largest on the right, 26. Okay, so our range for this third number, it could be anywhere between 6 and 26, but it could not be 6 or 26. It's just somewhere in the middle. So our answer would be 6 is less than x, which is less than 26. Let's look at another example of this. Let's say we're going to use the numbers 3 and 11. So on this one, again, we're going to have two inequalities. 3 is our smallest number. So 3 can go on the left for both of these inequalities. However, we're going to have to take the 11 and put it in one of the two spots. Either it's going to be on the left because it's the middle number, or it's going to be on the right because it's the largest number. So we have 3 plus 11 is greater than something, or 3 plus something is greater than 11. We need to know what that something is. We're going to put x. On the left, we got 3 plus 11, which is 14, greater than x. On the right, we got to subtract the 3, so we're going to have x is greater than 8. Again, we're doing the range where this is going to end up giving us 8 is less than x, which is less than 14, which is our actual range for x, which means it's somewhere between 8 and 14. Alright, so we can also use inequalities to give us what angles or sides are the biggest if we know some information. When we're taking the order of the angles of a triangle can be put in order by comparing the sides. The smallest angle is always opposite the smallest side. The largest angle is always opposite the largest side. So if we're looking at the one on the left, the smallest side is 7 feet. The middle side is 10 feet, and the largest side is 13 feet. So across from the 7 feet is angle A, across from the 10 feet is angle C, and across from the 13 feet is angle B. So if we're ordering from least to greatest, it's angle A, angle C, angle B. It works the same way with the sides. The sides of a triangle can be put in order by comparing the angles. The shortest side is always opposite the smallest angle. The longest side is always opposite the largest angle. So If we're looking at this, we need to first find what that third angle is. So we're going to do 103 plus 42, which gives us 145. Subtract from 180 gives us that our third angle is 35 degrees. So the order of our angles would be 35 degrees, 42 degrees, and 103 degrees. So across from 35 is segment ED. Across from 42 is segment DF, and across from 103 is segment EF. So that is our order from least to greatest. Now we can also do these with other numbers. So let's look at this example number 1. We've got sides 17, 24, and 20. We need it in order from least to greatest. So we get pick the smallest side first. The angle across from it is M. The second side is 20, so across from that is P. The third side is 24. Across from it is M, or N. So the order is angle M, angle P, angle N. We could also order it from greatest to least. We just go in reverse. Sides 8, 9, and 11. 11's the biggest. Across from that is angle C. 9's the middle. Across from that is angle B. And 8's the smallest. Across from that is angle D. So that's the order from greatest to least. We now are going to look at the sides. So on number 5, we have angle that is 31, an angle that is 57. If we add those up and subtract from 180, we find that our third angle is 92 degrees. So the smallest angle is 31, across from it is KL. Middle angle is 57, across from it is JK. Largest angle is 92, across from it is JL. So that is our order from least to greatest. On the next example, we have 82 degrees, 54 degrees. When we add those up and subtract from 180, we get 44 degrees. So we're ordering from greatest to least. The largest angle is 82. Across from it is XZ. This middle angle is 54. Across from it is YZ. And the smallest angle is 44. Across from it is XY. So that is our order from greatest to least. We can also use inequalities in two triangles. If two sides of a triangle are congruent to two sides of another triangle and the included angle of the first is larger than the included angle of the second, then the side opposite the angle of the first triangle is larger than the side opposite the angle of the second triangle. Alright, that's a lot to talk about. But basically what this is saying is if we look at these triangles, we have AB congruent to ED and AC congruent to DF. Right? If we know that angle A is larger than angle D, then we would know that segment BC is larger than segment EF. Basically, it's like opening a door. The door is not going to change size, but the more you open it, the larger the opening is. So you have a bigger angle and a larger opening. It's the same way, but now we're just talking about with triangles. And it works in reverse for the converse. Again, we're not going to read through the entire thing. If we know that that third side is larger than the third side of the second triangle, then the first triangle's angle A has to be larger than the second triangle's angle D. So now let's look at some examples with this. So first one here, we need to figure out which sides are congruent. We got JK congruent to NP and JL congruent to NM. Right, so we need to look at the included angle of both of these and compare them. Right, that is angles J and N. Angle J is bigger than angle N, so that means that the opening that J goes to, which is KL, must be greater than PM, which is the other triangles. Okay, on number 3, we have two sides that are 3, so they're congruent. And then we also have the line in the middle, so that's congruent by reflexive property. Problem with this one is we don't have the hinge angle, which it would be angle Z, which actually is WZX and XZY. So we need this third angle here to be able to compare it. So what we'd have to do is 32 plus 93, subtract from 180, ends up giving us 55 degrees. Now, since 55 is greater than 53, XY has to be greater than WX. And again, this also will work with the sides. So when we're comparing the sides, we have two sides here that are 25, and then we have the two sides that are 16. So we look at the third side. Since EF is 35 and GI is 33, EF's bigger, which means that angle D is bigger than angle H. And for the last one we're going to look at, we have two sides that are 17. QS is congruent by reflexive property. Now we look at the third side of both of these triangles. One of them is 13, the other one is 14. Since 14 is bigger, then we're going to know that angle TQS is larger than angle RSQ.